Hello, welcome to my talk. I am Dr. Brenda Reyes Ayala from the School of Library and Information Studies at the University of Alberta in Canada. And I'm going to be presenting on detecting quality problems in archive websites using image similarity. This presentation will cover some of the things that I was originally intending to present in last year's conference, as well as some new material. This is a quick overview of what I'm going to be talking about. So first, why should we care about similarity? The visual representation of information on the web has become an important part of judging the quality of archive web pages. A few years ago, I created a grounded theory of information quality in archive websites, where I define which facets of information quality were most important for web archives. Here, I want to talk about something called visual correspondence. And I define this as the similarity in appearance between the original website and the archive website. Ideally, when you are archiving a website, you want the archive website to look and function the same as the original. In this presentation, I focus on the visual correspondence or visual similarity. So I'm really only looking at the look of a website, of an archive website. How effective are different similarity measures at measuring the visual correspondence between an archive website and its live counterpart? In order to answer this question, we examine how the visual correspondence of an archive website can be measured using popular image similarity measures. Using these measures, we evaluate how visual correspondence can be used as an indication of overall archive quality. In order to calculate the visual similarity between archive websites and live websites, we created a set of tools called WA Screenshot Compare, which are currently freely available as a GitHub repository. So it goes through these steps in order to calculate visual similarity. One of the steps is to create the configuration file, where you specify the seed list, the collection ID and name of your collection, the method that you wish to use to take screenshots, the names of output files and directories, and the similarity measures to use. So there are 4 ways of taking screenshots that we have in our software. Puppeteer, which is the Python port of Puppeteer, Chrome, QtCapt, and Selenium. We are also able to close archive at banner websites. So we calculate similarity using 3 image similarity measures. First, there's the structural similarity index, the mean square error, and then the vector distance, which produces the distance between the RGB values of each screenshot. So, SIM, or the structural similarity index, calculates the similarity on a scale of -1 to 1, where 1 is perfect similarity. MSE calculates the similarity on a scale of 0 to infinity, where 0 is perfect similarity, and vector distance calculates the similarity on a scale of 0 to 1, where 1 is perfect similarity. We use 3 archivic collections on the topic of Western Canadian cultural heritage, and these are created and maintained by the University of Alberta Libraries. The first one is I Don't Know More, which are websites related to I Don't Know More, a Canadian political movement encompassing environmental concerns and the rights of Indigenous communities. The second one is Western Canadian Arts, which is a group of born digital resources created by filmmakers in Western Canada. And the third one is the Ferd McMurray Wildfire 2016, which are websites related to the wildfire of 2016 in the province of Alberta, Canada. So let's talk about the characteristics of some of these web archive collections. We were looking into how link rot was affected or had affected these web archive collections. We see that the I Don't Know More collection is the largest one with 196 seeds, followed by the Western Canadian Arts collection, and then finally the Ferd McMurray Wildfire 2016. Of these 3, I Don't Know More was the one that was most affected by link rot. In 2019, 92.9% of these seeds were still available on the web, but in 2021, 53.6% of these seeds became only 53.6% were still available. So a very large number of link rot happening here. We also deployed Memgator, a memento aggregator, to determine if copies of these websites were also present in web archives around the world. So there were actually only 2 places where these websites were captured. First, in the Archive.it, and these captures were created by the University of Alberta Libraries, and there was also the Internet Archive. So some issues that we encountered during the screenshot process. There was some breaking of the CSS styling sheet of the archive website, which we were able to fix using appending if underscore to each of the archive website URLs. It could be somewhat slow, and also webmasters might question why you are visiting their website so much to take screenshots. So it is a good time to develop your PR skills as a researcher and develop a 5-minute speech on why your research matters and why they should let you visit their website a lot. So let's look at some examples of an archive website. This is one with quality problems. On the left, you will see the current website. On the right is the archive website. So these are images for the website Cups and Cakes, which is a podcast. You'll see the SIM scores, the MSC scores, and the vector distance scores below. And just by visual inspection, you can see that there looks to be a missing style sheet, CSS style sheet, which is why only the text is around, but not really the look of the website has not been preserved. So you'll see that this is not the lowest score, it would be a 0 for vector distance or sim if it was a low score. So it's somewhere kind of in the middle. There's been some content that was preserved, but not everything. This is another example of an archive website with quality problems. So as you can see, this is a website for Intercontinental Cry, and you'll see that it has very low SIM scores, very large MSC scores, and very low vector distance. So as you can see, the website looks completely different. You'll see not only the style sheet is missing, but the appearance is missing. So this is an example of a high quality archive website, and this is the website for Daryl Nepinak, who is a Canadian artist. And you can see that the SIM score is 0.97, the MSC is 972.53, so fairly low, and the vector distance is 98.8. So these are scores that are quite high. So ideally, if you were a web archivist, you would not need to look at these scores any further. You say, okay, these are very high scores. I'm not going to bother actually manually going and looking at this website because it looks, it's probably very high quality. So we also performed a correlation analysis between different similarity measures. We found a weak negative correlation between SIM and MSC scores, a very strong negative correlation between MSC and vector distance, and a weak positive correlation between SIM and vector distance scores. So we had the initial hypothesis was there will be a strong correlation between SIM and vector scores, so this did not prove to be the case. There was an almost perfect negative relation between MSC and vector distance, suggesting that one measure might be easily substituted for another. Because we found MSC scores to be relatively difficult to interpret, we recommended the use of vector distance or SIM as measures of similarity. Then we perform a qualitative analysis of each of these screenshots and whether they were really, the similarities scores were really telling us what we wanted to know. So we found that vector distance can sometimes fail. They can sometimes produce a misleadingly high score when the quality is actually bad. So you'll see the screenshots of the website for the National Observer. On the left is the current website. On the right is actually a blank archive website. But you'll see that the vector distance is 93.44. So if you were just going to use vector distance, you would think, well, this is a very high quality archive website. I'm not even going to go in and manually check it. So you would not worry about it, but you see that the SIM score was actually not a number, which is often means that something went wrong. So So there can be other reasons for low similarity scores other than quality. You can have similarity scores due to content drift. So content drift is when the content of a website changes, but the website is still online. So it returns a 200 HTTP status code, but which leads you to believe that the website is actually online, but the content has just gone, and the website has been redesigned. So what we learned that it is important to conduct visual quality assessments early in the web archiving process while the websites collected are still online and accessible for comparison. Because if the websites go offline or if the content drifts, then it is very difficult to have these comparisons. So what we concluded is that it is possible to apply image similarity metrics in order to measure the visual correspondence and thus visual quality of archive websites. Not all image similarity metrics are created equal. Some can produce misleading results, and low sim scores can be indicative of possible QA problems. So I'd like to phrase my next step in terms of questions that I'd like to answer next. So how well do similarity measures match up with human judgments of visual correspondence in a web archive? And can similarity measures adequately detect the severity of QA problems? So a missing style sheet versus an entirely blank web page. So the acknowledgements is this project was supported in part by funding from the Social Sciences and Humanities Research Council of Canada. Thank you for your time and support.